My name is Nawarada binti Sabzafrin. My student ID is 2026-114-418. I am from Group AM1101B.
My name is Nur Ain Nabila binti Hisham. My matrix number is 2026113987 and I'm from group AM1101B.
My name is Nur Ali Shafana binti Muhammad Jafar and my student ID is 2026106563 and I'm from AM1101B.
My name is Nurdini Amni binti Muhammad Jeffrey. My student ID is 2026108379. I am from AM1101B.
Introduction of compound interest. Compound interest is the interest earned on both the original amount of money and the accumulated interest from the previous period. In simple words, the interest keep adding to the total amount and the new interest will be calculated with the bigger amount. Because of this, the money will grow more faster over the time compared to the simple interest. This concept is commonly used in saving accounts, investment and loans. The longer the money will kept in an account or investment, the more the interest will increase throughout the compounding process.
The problem statement is Nadia has been working as an accountant and plans to save her money in a Maybank fixed deposit account for her vacation plan. She intends to deposit RM8,000 for a period of 4 years, and the savings account offers an interest rate of 1.75% compounded every 2 months. Objective we want to achieve. First, to determine the accumulated amount at the end of the Nadia saving period. Second, to calculate the total interest received by Nadia. Third, to calculate the account balance at the end of the saving period when Nadia deposits an additional RM1,000 into the same account 3 years after her initial deposit. The last one is to calculate the accumulated amount at the end of the saving period when the interest rate changes to 1.95% compounded every 4 months, 8 months after her initial deposit. We need to create a timeline. A timeline will start with P, which is the principal amount, and ends with S, which is the accumulated amount. From that question, we can subtract that our K is our annual interest rate is 1.75% equivalent to 0.0175. And our M is frequency of conversion is 6 because it is compounded every 2 months, which is 12 divided by 2 is 6. And for our T, which is time length in years, is 4 years. To find I, which is our predict interest rate, we need to use the formula I equals to K over M, which is I equals to 0.0175 over 6, and we got 7 over 2,400. And after that, to find N, which is our numbers of interest period, we need to use the formula N equals to M multiplied with T, which is N equals to 6 multiplied with 4, and we got 24.
Objective 2, to calculate the total interest received by Nadia. The formula is I equals to S minus P. We will replace S and P with the information given earlier. So I equals to 8,579.90 cents minus 8,000. So we will get 579.90 cents.
Result in discussion objective 3. To calculate the account balance at the end of the saving period when Nadia deposits an additional RM1,000 into the same account 3 years after her initial deposit. Based on information given, Nadia principal amount, which is P1, is equals to 8,000. After 5 years, she decided to deposit an additional amount, which is P2, equals to RM1,000, and we need to find the account balance at the end of the savings period, which is S, after 1 year from the additional amount added. The annual nominal rate is 1.75% equivalent to 0.0175. The frequency is 12 over 2 equals to 6 because it compounded every 2 months. The periodic interest rate, which is I equals to K over M, equals to 0.0175 divided with 6, and the answer is 7 over 2,400. The first number of interest rate, which is N1, equals to M multiplied with T1 equals to 6 multiplied with 3, and the answer is 18. And the second number of interest period, which is N2 equals to M multiplied with T2 equals to 6 multiplied with 1, and the answer is 6. First step of objective 3, we are going to use the formula of S1 equals to P1 multiplied with plus I to the power of N1. S1 equals to 8,000 multiplied with 1 plus 7 over 2,400 to the power of 18. So the answer of S1, we are going to get RM 8,430 ringgit and 58 cents. For the second step, for the amount added, we are going to use the formula of P new equals to S1 plus P2. P new equals to 8,430 ringgit and 58 cents plus 1,000. So the answer of P new, we are going to get RM 9,430 ringgit and 58 cents. The last step in objective 3, we are going to use the formula of S equals to P new multiplied with 1 plus I to the power of N2. S equals to 9,430 ringgit and 58 cents. Multiply with 1 plus 7 over 2,400 to the power of 6. And the final answer of S, we are going to get RM 9,596 ringgit and 82 cents.
Objective 4, To calculate the accumulated amount at the end of the saving period, when the interest rate changes to 1.95% compounded every 4 months, 8 months after her initial deposit. Firstly, we need to construct the timeline consisting of P, the original principal amount, and S, the accumulated amount. P is 8,000 ringgit and S is what we will be calculating. The first term T equals to 8 months, which when we convert to year equals to 8 over 12, and we will get 2 over 3 years. And for the second term is 3 years and 4 months, and when we convert, it will be 3 plus 4 over 12, and we got 10 over 3 years. K1 equals to 1.75%, equivalent to 0.0175. The frequency M1 equals to 12 over 2, and we got 6. Then find I using K1 over M1, which is 0.0175 over 6, and we got 7 over 2,400. Then N1, calculate by multiplying M1 and T1, which is 6 multiply 2 over 3, and we got 4. Then K2 equals to 1.95%, equivalent to 0.0195. The frequency M2 equals to 12 over 4, and we got 3. Then find I2, which is K2 over M2, equals to 0.0195 over 3, and we got 13 over 2,000. And lastly, for N2, calculate by multiplying M2 with T2, which is 3 multiplied with 10 over 3, and we got 10. Now, to calculate the accumulated amount, the first step, we use the formula S1 equals to P multiplied by 1 plus I1 to the power of N1, which is S1 equals to 8,000 multiplied by 1 plus 7 over 2,400 to the power of 4. So we got S1 equals to 8,093 ringgit and 74 cents. Next, step 2, we need to find S. So we use formula S equals to S1 multiplied by 1 plus I2 to the power of N2. So S equals to 8,093 ringgit and 74 cents multiplied by 1 plus 13 over 2,000 to the power of 10. So we got S equals to 8,635 and 49 cents.
Introduction of annuity. An annuity is a sequence of equal payments made at equal periods of time. Interest, premiums, mortgage payments, interest payments on bond, payments of rents, payments on hire purchases, and dividends are a few examples of annuities. When the payments are made at the end of time period, the annuity is called an ordinary annuity. Examples include loan of repayments and interest payments on bonds. When the payments are paid at the beginning of each payment period, the annuity is called an annuity due.
Problem statement of case study 2. Hakim plans to buy a car for his daily use. He is interested in purchasing a used car Honda Civic 2018 model. The cost of the car is 58,800 ringgit. He plans to pay 20% as a down payment, and the remaining will be financed through a loan under Bank Islam Vehicle Financing Act. The bank offers an interest rate of 3.92% compounded monthly, and the loan will be settled to monthly payment over a period of 6 years.
Here are the objectives of annuity problem statement. First, to determine the amount of monthly payment by Hakim. Second, to calculate the total interest incurred by Hakim. Third, to calculate the outstanding balance if Hakim decides to settle the loan immediately after making the 70 payment. The last one is to determine the outstanding areas that must be settled in the next payment if Hakim missed 2 consecutive monthly payments.
Result in discussion. The account cost is RM 58,800 and it will be the cost price CP. He wants to pay the down payment of 20% from the cost price, so it will be RM 11,760. So to get the balance, CP minus DP, and we will get the answer of RM 47,040 and will be labeled as A. Next, K compounded equals to 3.92%, which is 0.0392. Compounded monthly will be M equals to 12. T, the period after loan, it will be 6 years. I equals to K over M, which is 0.0392 over 12 equals to 49 over 15,000. Last, and equals to M multiplied with T equals to 12 multiplied with 6, and the answer is 72.
Result and discussion objective 1. To determine the amount of monthly payment paid by Hakim. The formula is A equals to R multiplied with 1 minus in bracket 1 plus I to the power of negative n divided with I. We have to shift the R to the left side, so R equals to AI divided with 1 minus in bracket 1 plus I to the power of negative n. So R equals to 47,040 ringgit, I 49 over 15,000 divided with 1 minus in bracket 1 plus 49 over 15,000 to the power of negative 72. The answer of R is 734 ringgit and 24 cents.
Result and discussion objective 2. To calculate the total interest incurred by Hakim, we use the formula I equals to R multiply with N minus with A. So I equals to RM734.24 multiply with 72 minus with 47,040 ringgit. The answer of I is RM5,825.28.
Result and discussion objective 3. To calculate the outstanding balance if Hakim decides to settle the loan immediately after making the 70th payment. The formula of N unpaid is N unpaid equals to N total minus with N paid. So we get 72 minus with 70 equals to 2. So we use the formula A N equals to R multiply with 1 minus in bracket 1 plus I to the power of negative N divided with I. So A2 equals to RM734.24 multiply with 1 minus in bracket 1 plus 49 over 15,000 to the power of negative 2 divided with 49 over 15,000. The answer of A2 is RM1,461.32.
And the last objective is to determine the outstanding areas that must be settled in the next payment if Hakim meets 2 consecutive monthly payments. So first thing first, we need to find N unpaid, which is 2 plus 1 equals to 3. So for this calculation, we need to use formula Sn equals to R multiplied by 1 plus I to the power of N minus 1 divided with I. So S3 equals to RM734.24 multiplied by 1 plus 49 over 15,000 to the power of 3 minus 1 divided with 49 over 15,000. So S equals to RM2,209.92.
The conclusion of compound interest. Through this group project, we have gained a better understanding of compound interest, including its formulas, calculations, and practical applications in savings, also financial planning. From the studies cases, we learned how compound interest can help individuals grow their savings effectively with lower financial risk. In addition, this project helped us improve our teamwork, good thinking, problem solving, and financial calculation skills, which are important for making financial decisions in real-life situations. And the conclusion of annuity. In this group project, we also gained knowledge about annuity concepts and their applications in loan financing and repayment planning. This project made us understand how the repayment financial plan is structured and how annuity calculations are applied in real-life financial commitments such as vehicle financing. Besides, by improving our understanding of financial mathematics, this project also improves our communication, collaboration, and time management skills, which are useful for real-life financial decisions and can be applied to situations such as managing loan repayments and planning monthly budgets.